Today we'll be solving a latitude by meridian altitude question for the celestial body of Sun. Latitude by meridian altitude is also known as meridian passage or Merpass questions. The special thing about today's question is that we'll be using the concept of a back angle. So we'll be using the back angle of a sextant and deriving the ship's observed latitude using the method of a latitude by meridian altitude. So back angle, if you don't know what back angle is a value greater than 90 degrees. It is the altitude of a celestial body when the most obvious horizon is not available to us because of haze or fog, and we use the sextant to obtain the altitude of the celestial body on the opposite horizon. So in that case, the value of the altitude comes more than 90 degrees. So let's start with the question and you will get a better understanding of the problem then. Alright, so the question says that it's 1st of December 1992. Your dead reckoning position or DR position is 635 north, 6418 west, and owing to a hazy horizon to the south, a back angle observation of the sun's lower limb. So this is LL. LL stands for lower limb. So the back angle observation of the sun's lower limb on the meridian was made, and the sextant altitude was found to be 118 degrees 11.8 minutes. If height of I was 14 meters and index error was 2.4 minutes on the arc. So HOE stands for height of I and IE stands for index error. Determine the latitude and the position line. Alright, so one thing you have to remember before I start with the solution is whenever you see a meridian passage question, the position line will always be east-west. That is 090 to 270. I'll mention it at the end of the solution as well. But just remember, whenever you see a meridian passage question, the position line is always east-west or 090 to 270. Why? I'll show that to you as well later on. Alright. So the first thing we have to do now is to find out the GMT of the meridian passage for the date of 1st of September 1992. So of course we need the nautical almanac for 1982. Even if you don't have the nautical almanac, if you are using some other year and you are studying questions under some other year, it doesn't matter. What is important is you understand the method of solving these questions, and then you can of course go ahead and use the same method to solve the questions that pertain to your particular year. Alright, so let's start with the nautical almanac for 1992, 1st of September, and I have to find the meridian passage time. So I'll go into the nautical almanac, and you can see here I have 1st of September or 1st of December? I think it was 1st of December. I'm sorry, my apologies. 1st of December. So we have the 1st of December here, and I have to use my red pen, so you can see the 1st of December is here. On top the date is mentioned here. This is where 1st of December is, and I need the meridian passage time for the sun. So the meridian passage time of the sun is given somewhere here. So you can see for 1st of December the meridian passage time, this is the meridian passage time, is 11:49. Alright, this is 11:49. So this 11:49 hours is actually the LMT meridian passage or local mean time of the meridian passage. So this is where LMT meridian passage 11:49 is written. To this you will apply your LIT or your longitude in time. Now how do you apply your longitude in time? Well, longitude in time or LIT is equal to the longitude divided by 15. So in this case your longitude was 64 degrees 18 minutes. So you will divide 64 degrees 18 minutes by 15. And what you will get is 04 hours, 17 minutes and 12 seconds. Now, whether you add or subtract depends on your longitude. So if your longitude is west, your GMT will be best. That means your GMT will be more than your LMT. Longitude east, GMT is least, you would have subtracted from the LMT. So because your longitude is west, I'll write on the rule of thumb here, longitude west, GMT is best. That means GMT will be more than LMT. So you will add the longitude in time correction or LIT correction. Alright. So we'll start with that. So we added the 4 hours 17 minutes and 12 seconds of the LIT, and this is the GMT meridian passage. 1st of December, 16 hours 06 minutes 12 seconds, and this is the time you will be using to get your declination. So do not use your LMT. I have seen many students, they start using LMT time to get the declination. That is incorrect. Use the GMT meridian passage to get your declination. Alright, so we go back into the nautical almanac for 1st of December and we get the declination value and the D value. I'll show you what the D value is. So 16 hours is what we need the value for. So we'll go back. So 1st of December, 16 hours is here. Alright, and the sun is here. The sun column is here. So for 16 hours, we need the declination value, which is equal to 21 degrees 54.6 minutes, and this is south. 21 degrees 54.6 minutes south, and you can see the declination value as you go from 16 to 17 is increasing. So from 54.6 it's increasing to 54.9. Now this is very important because we'll be using this knowledge to apply our D correction value. So the D value is 0.4. Alright, the D value is 0.4. We'll be using the D value to get the D correction value. So the D value is 0.4 and we can see the declination is increasing. So we go back, we write down our declination. 21 degrees 54.6 is our declination. The D value of 0.4 is written here. Now I have to use this D value of 0.4 to go into the nautical almanac for 6 minutes and 12 seconds. Alright, and find out the declination correction. Now what is happening here? So let me explain what is happening here. Is that I'll erase the rest of it so that it doesn't become too cluttered for you guys. You have understood what to do now. So this declination value is for 16 hours, and the correction value we'll be getting from the nautical almanac from the increments will be for 6 minutes and 12 seconds, because we need the declination for 16 hours 6 minutes and 12 seconds, which is our GMT time, right? The declination was increasing as we went from 16 hours to 17 hours, so that's why I have put a plus sign here. If it was decreasing, I would have put a negative sign here. Alright, so if the declination is increasing to the next hour, you will be adding it. Now I'll be going to the increments page for 6 minutes and 12 seconds, 6 minutes and 12 seconds to get the D correction value for the D value of 0.4. So to do that, I'll have to go out of this almanac into a next page. Let's go here. 6 minutes and 12, 16 minutes, 6 minutes and 12 seconds. Is that right? So for this is for 6 minutes, so we don't need 12 seconds. We are not very important about that. So for 0.4, our correction is 0 minutes. So this is 6 minutes here, right? This is the increments page. For 0.4 of D value, so D value, the correction value is 0. Alright, so we go back, we apply a 0 correction. So that's why we applied the 0 correction here. You can see is 0. So it won't make a difference now. So if we add 0 to the original value, we still get the same value. So this is the declination for 16 hours 6 minutes and 12 seconds. Alright, so once we got the declination, okay, then the rest of it is pretty straightforward. We'll write down our sextant altitude 118 degrees 11.8, which is given to us in the question. Then we apply our index error, which is on the arc. So whenever the index error is on the arc, we subtract the index error. If it was off the arc, we would add it. And these are minutes, remember, okay? So don't put it under the degrees column, put it under the minutes column. This is where you have to be very careful. Sometimes students in a rush, they put it under the degrees column and then everything goes wrong there. So once you apply your index error, you get your observed altitude of 118 degrees 9.4 minutes. So OBS is observed altitude. Then you apply your dip. Your dip is nothing but your height of eye correction. I'll show you where you get your height of eye from. So your height of eye was 14 meters. So your height of eye is 14 meters, and so you need to apply your height of eye correction, which is always negative. So you go back into the nautical almanac. I'll go back and let me go into the right page. This is the right page. So you can see here, if I can highlight it, this is your dip column. This is for the height of eye correction. Alright, so height of eye is 14 meters, which is somewhere between 13.8 and 14.2, which gives you a correction of minus 6.6. Alright, so you will go back and apply this correction of minus 6.6. Fantastic. Height of eye correction is always negative, so you will always subtract it. Once you subtract it from the minutes, again from the minutes, remember, don't put it under the degrees column. You get your apparent altitude or APP altitude as 118 degrees 2.8 minutes. Now at this point of time, you will subtract your altitude from 180 degrees, because remember, this is your back angle. You took the altitude, you measured the altitude on the opposite horizon. Alright, so that's why the value is more than 90 degrees, which cannot be the case because normally the maximum altitude of a body is 90 degrees when it is at the meridian altitude. Alright, because you use the back angle, you've got a value of more than 90 degree. To do so you to correct for it, you will just subtract it from 180 degrees. So 180 degrees minus 118 degrees 2.8 will give you 61 degrees 57.2. So don't think it is 118 degrees 2.8 minus 180 and you get a negative value. Altitudes cannot be negative. Alright, altitudes will always be positive. So take the smaller number and subtract it from the bigger number. So bigger number is 180 degrees. So 180 degrees minus 118 degrees 2.8, which is your apparent altitude, will give you 61 degrees 57.2 minutes. So I'll write it down here so that you guys don't get confused on how I got this value. Alright, there you go. Alright, so whenever you see a back angle, after you apply your height of eye, you subtract it from 180 degrees. That is the special thing here when it is back angle. Then you apply your total correction. Where do you get your total correction from? So for an apparent altitude value of 61 degrees and 57.2 minutes, and for the date of 1st of December, you go into the same page where you got your height of eye from. So this is your total correction for the sun. Alright, your extreme left hand column. Your 1st December lies between October and March. These are the things you have to be very careful about. Alright. Now you have your lower limb correction and your upper limb. Now in the question it says it was lower limb. Right. So ideally we should be going under the lower limb column, stopping at 61 degrees 57.2, which will fall between these two values, which is our apparent altitude, and getting the lower limb correction of plus 15.7. But that will not be the case today. Because whenever you have back angle, this is another thing you have to remember. Whenever you have back angle, if the question says it's lower limb, you will take the opposite. You will use the upper limb value. So in this case, the upper limb is minus 16.6. If the question had said it was upper limb, you would have taken the lower limb value. So always do the opposite only when it is a back angle question. So in a back angle question, because the question said it's lower limb, I took the value of upper limb. I'll use the opposite. So I go back. I have applied minus 16.6 as the total correction, as you can see here. So when back angle, do the opposite. Use the upper limb. So because it was lower limb, I will use opposite upper limb. Alright. Now upper limb. So 61 degrees. So once I apply this correction of negative minus 16.6, I get the true altitude of 61 degrees 40.6 minutes. Alright. Now at this point of time you have to name the true altitude, and you have to name it same as bearing. Now what does that mean? I'll make it very simple for you. Alright. All you have to do is just draw a straight line. Alright. Put a letter Q. This Q stands for the celestial equator or equinoctial. Okay. Now what is your latitude here? Your latitude is 6 degrees 35 minutes north. Put yourself at north 6 degrees 35 minutes. Call yourself Z. This is U, zenith. This is you as the observer. I'll draw a little U here. Okay. Now this value here is 6 degrees 35 minutes north. Now why did I put 6 degrees 35 minutes north? Why did I put north of the equinoctial? Because this is the equator. It's same like the equator. If you are north, then you will be north of the equator, right? So if you are in the north latitude, you are north of the equator, even if it's a celestial equator. So we are putting you and the sun in the celestial sphere now. Now because it's a meridian altitude, the sun will be exactly on your meridian, will be lower or upper, we'll find out. Your declination of the sun is 21 degrees 54.6 minutes, which is south. So you will put the sun south of the equinoctial and you will call it X. This is the sun, celestial body. This value here is 21 degrees 54.6 minutes south. Again, because it is south, the sun was plotted south of the equinoctial, which is the celestial equator. Now, same as bearing, you have to name the true altitude. Now, we have to see where is the sun bearing from you as the observer. The sun is bearing south of you as the observer, right? So the sun is here, you are here, you are north of the sun. So the sun is bearing south of you. So whenever the sun is bearing south of you, you will name the true altitude south. Alright, that's why I have named it south. Same as bearing. And then subtract it from 90 degrees. Again, the smaller value from the bigger value. Subtract it from 90 degrees. What you get is the meridional zenith distance, or MZD. Your MZD is 28 degrees 19.4 minutes, because 90 degrees minus 61 degrees 40.6 is 28 degrees 19.4. Okay, so this value is 90 degrees minus 61 degrees 40.6 minutes. Then here you name it opposite to the true altitude. So whatever you have named your true altitude, you will name it opposite to true altitude. So you named your true altitude south, name your MZD north. Alright, and then write down the declination value that you calculated before, 21 degrees 54.6 minutes south. North and south, different names, you will subtract the value. If they were both north or both south, they would have been same names, you would have added them. Different names, subtract it and retain the name of larger. So retain name of larger. That means whatever is larger, in this case the MZD is larger, so you will call it north. You will call your latitude north. If your declination was larger, you would have called it south. So the MZD is larger, you will call the latitude north. There are different names, you will subtract. So subtract and you will get your latitude as 6 degrees 24.8 minutes. So this is your observed latitude, not your DR latitude. It will be close to the DR latitude but not exactly the same. So this is your observed latitude, which is a more accurate latitude because this is based on the celestial observation of a celestial body. Right? Now once you've got your latitude, that's it. I told you beforehand that position line is east-west 090270 in meridian passage question. Why is it that? Remember, I told you, I'll tell you why it is like that. Because again, remember, this is you, this is the sun, you are bearing south of the sun, the bearing is south, and position line is always drawn perpendicular to the bearing. So if I draw a position line perpendicular to the bearing, this is the position line and this is the position line perpendicular to the bearing. This is the bearing. So you can see the bearing is exactly 90 degrees because it's a vertical line, and that's why this position line is always east-west in meridian passage questions. Alright guys, so I hope this was useful to you, and I'll see you soon with my next video. This was a back angle special question, so let me know what you thought about this. All the best guys, see you soon.